think about what your summer was supposed to feel like. Warm evenings, a few afternoon thunderstorms rolling through, maybe some heat, then back to normal. That is what summer is supposed to do. It moves, it breathes. Systems come in, push through, and leave. That is the natural rhythm of the atmosphere. But what is happening right now, as of this morning, June 23rd, is something different. The atmosphere is stuck, not slowing down, stuck. And the longer this goes on, the more dangerous the situation becomes for tens of millions of people across this country. Today, I'm going to show you 3 things. The severe weather threat active right now from the high plains all the way to the mid-Atlantic, the heat building in the west, and the reason it is not going anywhere anytime soon, and the bigger picture behind all of it, including what a rapidly strengthening El Nino means for the rest of your summer and beyond. Stay with me through this entire video. The payoff at the end is worth it. I am Arthur. This is Sky Space Lab. If this is your first time here, I cover the data that the big networks do not have time to break down for you. Model by model, region by region, day by day. Hit that subscribe button so you do not miss what comes next. Now let us get into the data. The Weather Prediction Center released an updated short-range discussion just yesterday afternoon, and the headline says it plainly. An active summertime weather pattern will persist across parts of the central and eastern United States through midweek. That word, persist, is doing a lot of work in that sentence. This is not a one-day event. This is a series of atmospheric disturbances, one after another, interacting with abundant seasonal moisture across a corridor stretching from the high plains all the way to the mid-Atlantic coast. And each one of those disturbances is capable of triggering widespread showers and strong to severe thunderstorms. Here is who needs to be most alert today. The central and northern high plains are the primary focus for this afternoon and evening. The Storm Prediction Center is watching a supercell environment developing across a corridor from northeastern Colorado into eastern Wyoming and into southwestern South Dakota. The reason this setup is particularly dangerous is the combination of steep mid-level lapse rates and nearly 50 knots of mid-level flow overhead. That is the kind of environment that supports organized supercells, and when you get organized supercells in this kind of shear, large to very large hail becomes the primary hazard. We could see hail 2 inches in diameter or larger across parts of Wyoming and Colorado this afternoon. 2 inches is baseball-sized, and it comes down fast and without much warning. If you live near Cheyenne, Casper, or in the eastern Wyoming foothills, I want you to pay close attention to what happens between 2 and 7 this afternoon. A tornado or 2 cannot be ruled out. The Storm Prediction Center has been clear on that. If discrete supercells get going before the evening upscale growth, there is a window for rotation. That window is narrow, but it is real. By later tonight, most of the activity will transition into a more linear mode. Damaging wind gusts in the range of 60 to 70 miles per hour become the more widespread concern as storms cluster into a bowing line segment. But do not let the wind threat distract you from the hail earlier today. That is the first thing you need to be watching. Tell me in the comments where you're watching from today. Are you in the warning zone right now? What does the sky look like outside your window? Across the southern plains and into the lower Mississippi Valley, today brings a separate and significant flash flood concern. Precipitable water values are approaching 2 inches across parts of the Ohio Valley and into the mid-Atlantic region. Those are tropical level moisture readings for late June, and they are not going to drain quickly given how slow the overall pattern is moving. The WPC has a slight risk of excessive rainfall in effect today, stretching from the southern plains through the Tennessee Valley, the lower Ohio Valley, and into parts of the mid-Atlantic. That is a massive swath of the country, on alert for rainfall totals that can produce flooding in a very short amount of time. Cities like Nashville, Louisville, Charlotte, and Washington, D.C. need to be watching for quick-hitting heavy rain cells this evening. If you are in any of those areas and you see radar-indicated rainfall rates above 2 inches per hour, do not wait to move to higher ground. The storm complex moving through the Atlanta metro and the Carolinas earlier today has already demonstrated how fast these cells can produce locally heavy rainfall. The cold front trailing southward is going to keep tapping that moisture source through tonight. This is not a clean, organized frontal event where the rain comes and goes in an hour. This is a slow, inefficient pattern where clusters and cells keep firing along the same boundaries repeatedly. Now let us talk about tomorrow and what comes next. Wednesday, June 24th. The severe weather threat shifts but does not disappear. The Storm Prediction Center is watching a continuing corridor of supercell potential across the central high plains. Northeastern New Mexico into southeastern Wyoming is the focal zone. The mid-level flow stays persistent, the instability rebuilds through the afternoon, and we get another round of large to very large hail chances. This is a very repeating pattern. The same geography getting hit day after day. That matters for cumulative impacts. Infrastructure, crops, livestock. Repeated hail events compound the damage in ways that a single event simply does not. Farmers in this region are already dealing with the third significant hail threat in as many weeks. One note on Wednesday morning: check your radar before you head out if you're in Nebraska or the Dakotas. The Storm Prediction Center noted in their overnight discussion that some elevated storm activity is possible in the morning hours from northern Nebraska into southeastern South Dakota, right on the nose of a modest low-level jet. People tend to assume severe weather only happens in the afternoon. It does not. Some of the most prolific hail producers I have tracked have come between midnight and 8 in the morning, when a pulsing low-level jet keeps the atmosphere from fully stabilizing. Thursday, June 25th. The upper-level pattern amplifies. A surface low is expected to deepen across the southern high plains, and upslope flow strengthens along the Rockies Front Range. The SPC's day 4 through 8. Discussion specifically highlighted Thursday as a day when a passing mid-level jet streak and shortwave trough should result in scattered storm development across the high plains. The most likely corridor runs from northern Colorado into eastern Wyoming and into far southwestern South Dakota. Primary threats: large to very large hail, damaging wind gusts, and isolated tornado potential, particularly before storms upscale. This is a very typical setup for the northern plains in late June, but typical does not mean low end. Some of the most significant hail reports of the season have come from setups that looked routine on paper. The latest run just updated the timing on Thursday's setup, and the instability values are trending slightly higher than the previous model run. That matters for potential storm intensity. Friday, June 27th, is where things start to shift in a way I want to explain carefully. The upper-level trough that has been sitting off the Pacific Northwest coast begins to amplify and push inland this weekend. What that does is force a reorganization of the flow across the entire country. That shift opens the door for severe weather to spread eastward into the Midwest and Great Lakes by late this week and into the weekend. States that have had very little severe weather activity over the past month, Indiana, Ohio, Illinois, Michigan, move into the threat zone as we approach Saturday and Sunday. These areas have been under high pressure for most of May and into June. The instability is loaded. The moisture is backing in from the south and southeast. All the pattern needs is the right trigger to arrive. Indiana, Ohio, Illinois, make sure your severe weather plan is current. It has been quiet for a long time, but quiet ends this weekend. But here is where it gets really interesting, and I will show you exactly why in just a moment. The jet stream is the key to everything happening right now, and it is behaving in a way that I want to make sure you fully understand, because it is not going to change anytime soon. The pattern we have been locked in is what meteorologists call an omega block. That name comes from the shape of the jet stream when you trace it from west to east across the country. You get a curve that looks like the Greek letter omega, and what that shape means in practice is an atmospheric traffic jam. The normal flow of weather systems from west to east gets disrupted. A massive high-pressure ridge parks itself in the middle of the country. Low-pressure systems get squeezed to the north and south of that ridge, and nothing moves. The weather in each region just repeats itself day after day after day. The National Weather Service described it this way: blocking patterns like this are known to cause unusual weather, as high pressure jams the jet stream and displaces storm tracks to the north and south. This particular omega block has been locking in a stagnant split pattern, very warm and dry weather in portions of the north-central United States, cooler and wetter conditions along the coasts and the south, with slow-moving systems raising flood risks wherever they do occur. Here is what the WPC updated extended forecast confirmed just this afternoon. A relatively zonal upper-level flow pattern is expected for the beginning of Thursday, and the upper ridge over the southwest weakens after Friday. This will be due to an amplifying trough over the northwestern quadrant of the country over the weekend. That strong trough will support an organized low-pressure system emerging from the Rockies, to the central and northern plains, with a potent cold front crossing the Pacific Northwest and the Intermountain West. Most coverage will show you one day at a time. I want you to see the bigger structural reason why this week looks the way it does, and why next week will look similar. Now let us go deep on the heat, because while everyone is watching the storms in the central and eastern half of the country, the West is dealing with something that has been building quietly for weeks and is now crossing into genuinely dangerous territory. A strong and persistent ridge of high pressure has been anchored over the desert southwest and the interior west, and it is producing sustained, dangerous heat. In Texas, including Houston and the surrounding metro area, a building heat dome has been pushing temperatures higher while simultaneously increasing humidity. The combination creates hazardous heat index values. When it's 98 degrees Fahrenheit with a dew point in the upper 70s, the human body experiences conditions closer to 115. That is not just uncomfortable. That is life-threatening for the elderly, for young children, for people without reliable cooling, and for outdoor workers with no way to reduce their exposure. In Arizona, the situation has been even more severe. Grand Canyon National Park issued warnings after 3 hiker deaths, underscored how quickly extreme heat can become fatal in exposed canyon environments. Forecasters say the persistent high-pressure ridging across the southwest is expected to hold in the coming days, with above-average temperatures continuing across Texas and parts of the Gulf Coast, while elevated heat risk extends across the interior west. Phoenix is looking at potential highs above 113 degrees over the next several days. Las Vegas and Palm Springs are tracking similar numbers. There is a reason this heat is not breaking. The same Omega block trapping severe weather setups in the Central Plains is anchoring that western ridge in place simultaneously. These are not two separate stories. They are the same story told from opposite ends of the country, driven by the same atmospheric mechanism. The amplifying trough expected this weekend across the northwest will eventually begin to erode that ridge and bring meaningful cooling to the Pacific Northwest and Northern Rockies. But the desert southwest is looking at consecutive days of extreme heat before any relief arrives, and nighttime temperatures that refuse to drop below 90 degrees rob the human body of the recovery window it needs. That is when heat becomes most dangerous, not during a single hot afternoon, but during extended stretches with no overnight cooling. How is your area handling this heat? Drop your city in the comments right now. I want to know if you're seeing the cooling effects from the incoming trough or still sitting under the full force of the dome. There is a drought story running underneath all of this that is not getting enough attention. The drought developing across the interior west, through parts of Montana, Idaho, Nevada, and Wyoming, has been one of the quieter narratives this spring. But it matters enormously for wildfire risk as we push deeper into summer. Heat, low relative humidity, and dried out vegetation create the conditions for explosive fire growth. Lake Powell, the largest reservoir in the country, was sitting at 3,528 feet above sea level as of early April, approaching the critical elevation of 3,490 feet, the level below which Glen Canyon Dam cannot safely generate hydroelectricity. Bureau of Reclamation managers warned the reservoir could fall below that threshold as early as August. If that happens, it is not just a water story, it is an energy story, it is an infrastructure story, and the heat dome is accelerating that timeline. The drought and the heat dome and the Omega block are all connected. Understanding one means understanding all three. Let me put some specific numbers on what the Omega block means in practice for the regions most affected. Across the southern tier, Texas, Louisiana, Mississippi, Alabama, Georgia, and Florida, the WPC's extended outlook is showing a wetter-than-normal pattern persisting well into the first week of July. Rainfall totals over the next 7 days across the Arklatex region could reach 3 to 5 inches in some locations. Parts of central Texas that have been in moderate drought are going to see that deficit partially erased, but at a cost. Heavy convective rainfall in areas with parched, compacted soil generates immediate runoff rather than infiltration. The flood risk is real even as the drought begins to recover. Across the northeast, the pattern is also worth watching. The east side of the Omega block has been keeping troughs locked in place along the east coast, bringing cooler than average temperatures across southern New England and the mid-Atlantic. New York City, Philadelphia, and Boston have been running 5 to 8 degrees below normal for high temperatures in recent days. That is a direct consequence of the blocked jet stream. The trough cannot advance eastward because the western ridge is holding it in place like a doorstopper. What changes that dynamic is the incoming amplification from the Pacific. As that trough deepens over the northwest this weekend, it sends a ripple through the entire pattern. The east side trough weakens, the central ridge begins to lose some of its grip, and the storm track, which has been displaced north and south, starts to reorganize into a more traditional west to east flow for the interior of the country. That reorganization is what makes next week's setup potentially so significant for the Midwest and Great Lakes. The SPC's extended range discussion flagged this explicitly. Beyond day 4, there will likely be multiple days with eventual severe weather probabilities given the amplifying trough across the northwest, and moderate mid-level flow overspreading the northern plains where instability will also be quite strong. That is a significant statement for a forecast product that rarely projects that far with confidence. The consistency of the signal across multiple model runs is what drove that language. Now I want to connect all of this to the larger planetary scale forcing, because none of what is happening is occurring in isolation. What the IRI Columbia modelling team, the ECMWF, and NOAA's Climate Prediction Center have all been tracking for months is the accelerating development of El Nino in the tropical Pacific, and the latest data is striking. The Nino 3.4 index has surged to positive 0.9 degrees Celsius, already past the El Nino threshold of positive 0.5 and approaching moderate El Nino status. NOAA officially issued an El Nino advisory on June 11th, confirming that El Nino conditions are now present and expected to strengthen further. The rate of increase here is what commands attention. It has been faster than the build-up to either the 1997 event or the 2015 event, both of which became two of the strongest El Ninos in the recorded historical record. The ECMWF probability tracker went from 22% in March to 80% in April to 100% super El Nino probability in May. That is not a gradual ramp. That is an acceleration unlike most of what we have seen in the modern record. NOAA's Climate Prediction Center now assigns a 63% chance of sea surface temperatures exceeding 2 degrees Celsius above average by November through January. That is the threshold for a very strong event, and CPC has publicly called a super El Nino the single most likely outcome for late 2026. Most channels are not showing you this part, but it matters for everything you're going to experience for the next 12 months. The Eastern Pacific Nino 1+2 region, the zone closest to the South American coast, is currently running at positive 2.1 degrees Celsius above average. The subsurface Kelvin wave propagating eastward across the equatorial Pacific is showing temperature anomalies of positive 8 degrees Celsius at depths between 50 and 250 meters. Those warm anomalies have not yet fully reached the surface. When they do, the Nino 3.4 index will jump again. The ECMWF and BOM models are projecting sea surface temperature anomalies reaching positive 3 degrees Celsius by late 2026. That would rival or surpass the strongest El Nino in the recorded historical record going back to 1877. James Hansen, the NASA climatologist who first warned Congress about climate change in 1988, published a paper in April of this year that he specifically titled Super Duper El Nino. His thesis, even a moderately strong El Nino in 2026 will produce record global temperatures because the background warming baseline has accelerated so significantly. Add a very strong or super El Nino on top of that already elevated baseline, and the implications for weather patterns through 2027 become genuinely extraordinary. What does this mean for your summer? Let me give you the model-by-model picture. Let me walk you through the El Nino teleconnection pattern that specifically matters for your severe weather risk this summer. When El Nino strengthens the subtropical jet over the southern United States, it does something counterintuitive for the northern plains and Midwest. It actually increases the frequency of strong shortwave troughs rotating through the mid-levels, the same features that act as the trigger mechanism for supercell thunderstorms. Climate Impact Company and AccuWeather Seasonal Guidance both flagged this mechanism in their June outlooks. The southern tier wetness from El Nino is the headline, but the secondary effect on shortwave activity over the Great Plains is what the severe weather community is watching closely. CSU's Phil Klotzbach noted in the June 10th Hurricane Forecast Update that the rate at which El Nino reaches strong conditions will determine how much of the Atlantic season is suppressed, and that right now all indicators suggest the suppression will intensify rather than relax as we move into August and September. That matches what the ECMWF subsurface temperature analysis is showing. The warmest water anomalies in the Kelvin wave are still propagating eastward and have not yet fully expressed at the surface. When they do, the Nino 3.4 index will accelerate again. The WMO's chief of climate prediction specifically confirmed high confidence in El Nino onset, followed by further intensification. That is not hedge language. That is a clear directional statement from the world's top climate prediction body. The IRI Columbia forecast and the ECMWF are in agreement on the following. The subtropical jet stream over the southern United States is being enhanced by the warming tropical Pacific. That enhancement is what is driving wetter, stormier conditions across the southern tier of the country, particularly from Texas through the Gulf Coast states and into Florida. That pattern is going to continue and likely amplify as El Nino strengthens through the fall. More moisture, more Gulf moisture, more flooding rainfall potential along the southern tier. NOAA's Climate Prediction Center is already forecasting wetter than average conditions across the southern United States for the months ahead. For the northern half of the country, the El Nino signal is typically warmer than average through fall and into winter. The drought building across the Pacific Northwest and northern Rockies will be difficult to break. Snowpack deficits that are already present will deepen rather than recover. This is one of the strongest El Nino development rates I've seen in the data going back decades. The analog years, 1997, 2015, 1982, all became super events. All of them rewrote the weather calendar for the following year and in some cases for several years afterward. I am not saying this year will match those years exactly, but the trajectory is clear enough and the data is consistent enough that you deserve to know what you could be looking at through the remainder of this year and into early 2027. Before we wrap up, there is one more thing you need to know, and this is the part I have been building toward. The Atlantic hurricane season opened on June 1st with zero tropical activity across the entire basin. Satellite imagery confirmed dry air and strong upper-level winds everywhere the National Hurricane Center monitors. Not a single area of concern in any NHC tropical weather outlook for the opening days of the season. And the primary reason for that silence is exactly what I just described. Here is how El Nino suppresses the Atlantic mechanically. When the tropical Pacific warms, it drives rising air over the eastern and central Pacific. That rising air has to descend somewhere. It sinks over the tropical Atlantic. Sinking air suppresses thunderstorm development and limits the convective activity that hurricanes need to form and intensify. Simultaneously, the warming Pacific changes the wind structure in the upper atmosphere, injecting strong upper-level winds across the tropical Atlantic. Strong upper-level winds mean vertical wind shear, and vertical wind shear tears apart tropical systems before they can organize into anything significant. The numbers from the major forecast centers are telling a consistent story. NOAA's 2026 Atlantic Hurricane Season Outlook, issued May 21st, forecasts 8 to 14 named storms, 3 to 6 hurricanes, and just 1 to 3 major hurricanes, with a 55% chance of a below-normal season. Colorado State University went further on June 10th, lowering their forecast to just 11 named storms, 5 hurricanes, and 2 major hurricanes. That is roughly 40% below historical average activity. CSU noted that if this forecast materializes, hurricane activity would be approximately 40% below the long-term average. The entire United States coastline has just a 24% chance of a major landfalling hurricane this year. The historical average is 43%. The US East Coast, including the Florida Peninsula, sits at 11% versus a historical average of 21%. Those are significantly reduced odds, nearly cut in half compared to a normal year. When GFS and Euro and the NHC seasonal forecasts all agree on reduced activity, you pay attention, but you do not stop preparing. Here is the line from CSU I want you to hear directly. Even a less active season can produce dangerous landfalling storms. One storm on the right track can produce catastrophic impacts regardless of what the seasonal average says. We saw that in 2015, a strong El Nino year, when Hurricane Joaquin became a Category 4 storm and caused serious damage across the Bahamas. Below normal does not mean no threat, it means reduced probability, not zero probability. The area I am watching most carefully right now is the Western Caribbean and the Gulf. The El Nino shear pattern is currently directing strong upper-level winds toward the Western Gulf, which limits development there for now. But shear is not static. As this pattern evolves over the next 2 to 3 weeks, there will be windows where shear relaxes across parts of the Eastern Gulf, and the Western Caribbean. The Gulf water temperatures are warm, sea surface temperature anomalies across the Western Caribbean and the southeastern Gulf Basin are above average right now. A tropical wave that finds one of those shear windows could develop rapidly given the ocean heat available. The GFS ensembles have been showing scattered low-pressure signals in the Gulf and Western Caribbean in the 10 to 14-day time frame. The ECMWF is picking up similar signals, weak, disorganized, but present. The NHC tropical weather outlooks are showing Saharan dust over the Atlantic beginning to thin over the next 2 weeks as the ITCZ precipitation zone lifts northward. That northward lift is what begins to fuel African tropical waves more effectively as we move into July. As June gives way to July, those waves will wade into a more moisture-rich environment than what they currently encounter. I am not forecasting a hurricane. I want to be clear and direct about that. The ensemble members are not showing a high-confidence development scenario in the immediate term, but with El Nino still ramping up rather than fully established, the suppression mechanism is not yet operating at full strength. That gap, the transition window between current conditions and a fully locked-in El Nino suppression regime, is precisely the period I am watching most carefully. There is one more dimension to the tropics story that I want to make sure you understand before I let you go, because it is the thing that makes this particular moment different from a typical quiet start to the Atlantic season. The Atlantic sea surface temperatures, even in a below-normal hurricane season forecast, are not cold. They are near or slightly above average across parts of the tropical Atlantic. The El Nino suppression mechanism works through the atmosphere, the wind shear and the sinking air, not by cooling the ocean. So what you have is an atmosphere that is hostile to hurricane development sitting on top of an ocean that is thermally capable of supporting it. That tension is important. It means that any storm which does manage to form during a rare window of reduced shear will have fuel available. It will not be constrained by cold water. It will only be constrained by how long the atmospheric window stays open. That is why I keep watching those ensemble signals in the Gulf and Western Caribbean so carefully. Not because I expect a hurricane in the next 2 weeks, but because the ocean is loaded, and all it takes is one brief period of relaxed shear to give something a chance to spin up. The NHC is watching the same thing. Their updated tropical weather discussions this week specifically note the possibility of increased convective organization near Central America and in the Bay of Campeche region as we move into the last week of June. That language is early stage, low confidence. But it is there. Stay subscribed, stay watching the data, because if the picture in the tropics changes, even slightly, I will cover it immediately. That is my commitment to you. What is your biggest concern heading into the rest of this summer? The heat building in the west, the repeated severe storms across the plains and Midwest, or the potential for a surprise in the tropics? Tell me in the comments below. Your responses shape what I focus on in the next video. If this breakdown helped you understand what is a genuinely complex and interconnected weather pattern, share it with someone in one of the threat areas we covered today. The like button helps this channel reach more people who need this information. And subscribe if you're not already here, because tomorrow I am going to be watching the trough amplification over the Pacific Northwest very closely. There are model signals suggesting a faster than expected breakdown of the western ridge beginning as early as this weekend. If that plays out the way the latest GFS and ECMWF runs are suggesting, it changes the heat timeline meaningfully for parts of the South and the Central Plains, and it may accelerate the severe weather threat for the Midwest. I will have the full updated picture for you tomorrow. Stay weather aware, stay informed. The pattern is not done with us yet. The data will tell the story. It always does.